Alright, welcome to my YouTube channel once again. I'm still the boiling point. Please do well to subscribe. So this is the continuation of the scalar and vector quantity from the place we stopped. So we stopped at question number 6. So please, if you've not watched my previous video, please go and watch it. So we are going to be starting on question number 7. Okay, question number 7. They said if a force F is equals to I plus 2J plus K displaces a particle from arrow 1 to arrow 2, the work done is dash. Option A, 3ij, option B, 4j, option C, 6ij, and option D, 6j. Now, how do you solve this? For you to be able to solve this question, you must understand what is called vector multiplication. There's what we call multiplication of vectors. And there are two ways in which we can be able to multiply vectors. So the first way of vector multiplication, the first one is called dot product. It's called dot product. If you don't call it dot product, you call it scalar product. So another name for dot product is called scalar product. The second one of multiplying vector is called cross product. Cross product. Or you say it's vector product, anyone, vector product. But meanwhile, what determines the formula, whether it's dot product or cross product, is dependent on the options. Check the options, you discover that we have how many dimensions of vector here? About 2 dimensions or 3 dimensions. But if you check the options, you discover that it just gave us magnitude. Remember, the quantity that has magnitude only is called scalar. Therefore, we use what we call scalar product, which is dot product. So how do we solve this? Or watch. For us to be able to solve this, the first thing you ask yourself, what are we calculating? You're calculating for work done. And what is work done? Work done, which is W, is equals to force times the distance. Force times the distance. But in this case, we will not use times. This is multiplication. So I will have it that work done will now be force dot distance. Force dot distance. So the question now is, did they give us force? Yes, they gave us force. The value of force here is I plus 2J plus K, which is measured in Newton, right? That is the unit. Then did they give us distance? No, they didn't give us distance. Okay, they gave us distance. Now, but the distance they gave us here is from arrow 1 to what? Arrow 2. So we'll move from arrow 1 to arrow 2. That means we'll find the change in displacement. Change in displacement, which is D, is equals to arrow 2 minus arrow 1. So the question is, what is arrow 2? Arrow 2 is J plus K. J plus K, then minus, open bracket. What is arrow 1? Minus I, minus 2K. Are you seeing that now? So what will be my distance? My distance will now be J plus K. Minus times minus is plus. So minus 1 times minus I is plus I. I'll have it as plus I. Then minus times minus is also plus, which is plus 2K. So the next thing is what we call collection of like terms. Let's do the collection of like terms. I have J, I have K, 1K, 2K. So plus 1K plus 2K will give me what? Plus 3K. So at the end, I will have it as I plus J plus 3K. So this is just the distance. They will not apply the formula for dot product. Let's solve it. So now we know our force and we know our displacement. So we'll now solve. I will now have that the dot product of F and D will be equal to, what is force? I plus 2J plus K. So what is distance or displacement? I plus J plus 3K. Now we've been able to do this. You will take the multiplication of the coefficients of the directions. What is the coefficient of I here? 1. What of here? 1. So 1 times 1 is 1. What is the coefficient of j here? Plus 2. What of j here is 1. Plus 2 times 1 is plus 2. What is the coefficient of k here? 1. What of here? Plus 3. So I'll have plus 1 times plus 3 is plus 3. So I will now have that the dot product of f and d will now be equals to 1 plus 2 is 3. 3 plus 3 is 6. Therefore, I will now have the work done, which is the dot product of force and displacement, is equals to 6 joules. So do we have 6 joules in the option? Definitely yes. Option A is 3ij. No, it can be 3i because they gave us direction. So if they gave us direction, it is not a scalar product now. It is now a vector product. So this one they gave direction can never be the answer. 4 joule is not the answer. So it's not the answer. 6i, no, because of the presence of this I, it is not the answer. So 6 joules, yes, that is the answer. Question number 8. Question number 8. Question number 8. So how do we solve question number 8? I will look up. They say 6 kg object is subjected to 3 forces. I have 3 forces here. We have 20I plus 30j Newton. F2 is equals to 8I minus 50j Newton, and F3 is equals to 2I plus 2j Newton. Find the acceleration of the object. Okay, first of all, in physics, remember what I told you, you must bring out what is called data. Now, they say 6 kg, that means they gave us mass. They gave us mass. The mass of the object is 6 kg, right? So, and they say we should find the acceleration. The acceleration is unknown. And they gave us force. But here you discover that we have 3 forces. But guess what? Just pay attention to this now. The first force, which is F1. What is the value of F1? 20I plus 30J. What of F2? F2 will now be 8I minus 50J. What of F3? F3 will now be 2I plus 2J. So what did you observe? You observe that all of them have I. Then you also observe that all of them have what? J. That means these vectors are moving in the same direction. So if they are moving in the same direction, what do? You add. So if you have more than 1 or 2 vectors that are moving in the same direction, what do? You add. That means I will get the net vector. The net vector will now be F1 plus what? F2 plus what? F3. So we will now calculate this. So I will now have, get the summation of all of them. I will now have plus 20 plus 8 plus 2. 20 plus 8 is 28. 28 plus 2 is 30I. So I have this in as 30I. Then I will now have plus 30 minus 50. Plus 30 minus 50 will be minus 20. Minus 20 plus 2 will now be minus 18. But let's work it out. 30 minus 50 plus 2. So minus 18. I'll have it as minus 18J. So therefore, our F net. What is our F net? 30I minus 18J. Now we are not looking for F net, we are looking for acceleration. Recall from the second law of Newton that F is equals to, in this case is F net is equals to NA. So we'll make A the subject of the formula because we are looking for acceleration. So you have that A will now be F net all over what? M. Do we have our F net? Yes. What is our F net? 30 minus 18 joule. All over, what is the mass here? 6. So 30 divided by 6. What is 30 divided by 6? 30 divided by 6 should be 5, but let's still check. It's 5. I'll have it as 5i, right? 5i. Then 18 divided by 6 is 3 minus 3j, and that is the final answer. If you watch this, okay, yes, that is the final answer. So do we have anything like that in the option? Option A is 5i plus 3j. No, it can't be the answer. Option B is 5i minus 3j. Definitely this is the answer. So let's go to question number 9. Question number 9. Question number 9. Question number 9. Okay, in question number 9, they say find the value of alpha such that A is equal to, it gave us the value of A. What is A? A is equals to 2i plus alpha j plus k. And B is equals to I. What is B? B is I plus 3j minus 8k. Are perpendicular. So they say they are perpendicular. So we should find the value of this word alpha. Now, if you hear the word they are perpendicular, it means that the angle sustained is angle 90. If it is angle 90, remember what I told you in the previous video, that the dot product of two vectors, if they are perpendicular, is equal to 0. I was able to prove this. And I said that the reason is because the formula for dot product is equals to magnitude of vector A times magnitude of vector B, then cos theta. So if theta is 90, what is cos 90? 0. So 0 multiply everything here will give you what? 0. And that is the reason why the dot product of two vectors that are perpendicular to each other is equal to what? 0. Please note it. So if it is equal to 0, what I'm going to do is that I will have to find a dot product between A and B. So what is the dot product between A and B? So I have it as 2i plus alpha j plus k. Then I have I plus 3j minus 8k. So find it. 2 times, what's the coefficient of I here is 2. What's the coefficient of I here is 1. 2 times 1 is plus 2, right? Which is 2. Plus alpha times plus 3 is what? Plus 3 alpha, right? Then plus 1 times minus 8 is minus 8. Remember that the dot product between both of them, everything is equal to what? 0. So collection of line terms. Remember, I will have it as 2 minus 8. What is 2 minus 8? Which is minus 6. We have it as 3 alpha minus 6 is equal to what? 0. So minus 6 will cross the equality sign, will change to plus 6. You have it that 3 alpha is equals to 6. When they make alpha the subject of the formula, by dividing by 3, divide by 3. This will cancel this. So what is alpha? 6 divided by 3. 6 divided by 3 is 2. So alpha is 2. So do we have 2 in the option? Definitely yes, which is option A. So we are done with question number 9. We will now move to question number 10. Question number 10. What are they asking us in question number 10? They say question number 10, that two vectors are equal in magnitude but traveling in opposite direction. The resultant is dash. Let me still repeat it. Two vectors are equal in magnitude but they are traveling in opposite direction. What is the resultant? The resultant is dash. A 0, B double, C half, D twice the magnitude. Okay, let's analyze this question. I have two vectors and they say they are equal in magnitude. That means the magnitude is equal. So these are the two vectors. Let me say this is vector A and vector B. If they are equal in magnitude, that means let me say vector A is something like 4 Newton and vector B is 4 Newton. 4 Newton means that they are equal in magnitude. So, and they gave us further information, but they are traveling in opposite direction. So if they are traveling in opposite direction, that means this one is traveling this way, this one is also traveling this way. So the magnitude here is 4 Newton, the magnitude here is 4 Newton, right? Now, if the magnitude here is 4 Newton, the question is, what is the resultant? Now, definitely, if you have two vectors and they are moving in opposite direction, what do? You subtract. So let me repeat myself. If you have two vectors and they are moving in opposite direction, what do? You subtract. So if you subtract, you have that the resultant vector will be 4 minus 4. What is 4 minus 4? 0. So, but if you don't want to solve it this way, you want to also solve it using another method. Now, guess what? If they are traveling in opposite direction, that means the angle here, what is the angle here? The angle here is 180 degree, which is angle in a straight line. So if it is angle in a straight line, I'll have it as 180 degree. Any question you want to solve related to vector, especially that has two magnitude. Now, this is the formula you apply. You have it that the resultant vector will be arrow square is equal to a square plus b square plus 2 times a b then cos theta. This is how to find the resultant for any vector at all. Any vector. So I will now have it that arrow square, let's calculate it. What is a square? 4 square plus 2 times 4 times 4. Remember that what is theta? Theta will be cos 180. You get that now? Let's check. What is cos 180? What is cos 180? I'll have it as cos 180. Okay. 180 is equals to minus 1. So cos 180, everything here is minus, that is here is minus 1. Now what is 4 squared? 4 squared is 16, Abi, plus 16, Abi, plus 2 times 4 is 8. 8 times 4 is 32. 32 times minus 1, that is minus 32. So here I'll have it as minus 32. You get what is 16 plus 16? 32. I'll have it 32 plus minus is minus, which is minus what? 32. Are you getting me? So 32 minus 32. Remember, I'll have it 32 minus 32 is what? 0. So square both sides. If you square both sides, what is really our arrow is also equal to 0. Are you getting me? So any question you want to solve related to anything called vector has two magnitude, use this format. Then question number 11. Question number 11. That means the number 10 we solve. What is the answer here? Option A says 0. So the answer is 0. Question number 11, you have it as 2 force of 20 Newton acts at an angle 30 degrees to the horizontal. Then they ask you to calculate for the horizontal component. Okay, I have a force of 20 Newton, a force. So if I have a force of 20 Newton, that means I have something like this. This is the horizontal, right? This is the vertical. Then they said this force acts at, this is the force. And what is the magnitude of the force? 20 Newton. It acts at 30 degrees to the horizontal. So this is 30 degrees to the horizontal. Then they ask me the horizontal component is dash. That means we are looking for fx. Now, how do you solve this? Any place that is closed, use cos. Any place that is open, use sine, right? Now, is it the horizontal or the vertical that is closed? You discover that, or is it the horizontal or the vertical that sustains the angle? it is the horizontal, right? Now this place is closed. If it is closed, that means the horizontal will be cos. If here is open, that means the vertical is sine. But we are not looking for the vertical component, we're looking for the horizontal component. That means the horizontal component, which is f of x, will now be equal to 20 cos 30. 20 cos 30. I will have it as 20, then cos 30. What is 20 cos 30? I will have it as 10 root 3. And what is 10 root 3? 10 root 3 is 17.3 Newton. I have it 17.3 Newton. So do I have anything like 17.3 Newton in the option? I have option A is 10 Newton, option B is 17.3 Newton. So the correct answer is option B. Please do wait to subscribe to my YouTube channel. Remember, I'm still the boiling point. Meet me in my next video. I'm going to be talking about unit and measurement together with work, energy, and power. Thank you. God bless you.